In lesson 5.5, we're going to apply the remainder and factor theorems, but first we'll review long division. I'm going to take my divisor, put that over to the left, x squared minus x minus 2. Here's my division bar. The dividend is going to go beneath that, so that will be x cubed plus 3x squared. We do not have an x value, so we need a placeholder of 0x minus 7. We look at the first term in the divisor, and then we look at the dividend, and we ask ourselves, x squared times what would get me to x cubed? And that would just be a plain old x. Now we multiply that x into every term in the divisor. So x times x squared, x cubed, minus x squared, minus 2x. Then we'll subtract this trinomial from above. We are distributing the negative, or you could think of it as add the opposite. Our x cubes cancel, 4x squared plus 2x, and we bring down the minus 7. Now we ask ourselves, x squared times what would get me to 4x squared, and that will be 4. 4 times x squared, 4x squared, 4 times negative x, negative 4x, and 4 times negative 2 is negative 8. Again, we subtract. I'm going to change my signs, add the opposite, cancels 6x plus 1, and this is my remainder. The remainder will be written over the divisor, so 6x plus 1 over x squared minus x minus 2. The degree is higher in the divisor than it is in the remainder, so that is how we know it is finished. We can check our answer by multiplying the divisor with the quotient and then adding in the remainder. And I'll show you what that would look like. If I multiply the quotient by the divisor, add in the remainder, we should get back to x cubed plus 3x squared minus 7. Synthetic division can be used to divide any polynomial by a divisor of the form x minus k. So I'm going to set that up. Because the divisor is x plus 3 and we are using the form x minus k, we can think of it as x minus a negative 3. That is why we have a negative 3 to the left. We bring this 3 down. Negative 3 times 3 is negative 9. 17 and negative 9, 8. Negative 3 and 8 is negative 24. We add those, we get negative 3. Negative 3 and negative 3 is a positive 9. And we end up with a negative 2. Now we're going to compare this answer to long division. This is actually pretty cool. So remember, our divisor was x plus 3. And you'll see that our coefficients match the results from our synthetic division. So 3, here's our coefficient, 8, and then the negative 3. But now we have this negative 2. This negative 2 is actually the remainder when we use long division. The remainder theorem states that if a polynomial f of x is divided by x minus k, then the remainder is f of k. So what that means is if I take the -3 from the synthetic division and sub it back into the dividend, which I did here, the result will be the remainder, and in this case it was -2. The factor theorem states that a polynomial f of x has a factor x minus k if and only if f of k equals 0. So we would use this if we're given one factor and asked to find the others, or given one zero of a polynomial function and asked to find the others, or thirdly, when given one solution and you're asked to find the others. Let's look at an example. So for instance, we're given this polynomial, and we're also told that one of the factors is x plus 2. So we can use synthetic division to factor. And I want to remind you that x minus k is the form, so it's really x minus a -2. Using synthetic division, we brought down the 3. -2 and 3 was -6. We added -10, -2, -10 is 20, added -8, -2, -8 is 16, added, we got 0. They gave us x plus 2 as one of the factors. Then we took the 3, the 10, and the -8 to create our trinomial, and we can factor one more time. We have x plus 2, 3x plus 2, and x minus 4. We could have been told that one zero or one solution of the polynomial is x equals -2, and we can see that here. X plus 2 equals 0, x equals -2. Again, we'd use division to get to this point, and then apply the zero product property and solve for our other zeros. I set the factored form to 0, so x plus 2 equals 0, 3x plus 2 equals 0, x minus 4 equals 0. Subtract 2 from both sides, x equals -2, subtract 2, 3x equals -2, divide both sides by 3, x equals -2 thirds, and add 4 to both sides. X equals 4. When we started, we said that we would use the factor theorem to find other factors if we're given one, or given one zero of a polynomial function or one solution, and we can find the others.